Absolutely, there is life elsewhere and almost certainly intelligent life. It has to be, the odds are just overwhelming. Voyager 1 has been our silent ambassador to the stars for decades, and now the stars have responded. According to Bill Nye, the Voyager missions were a testament to human curiosity and ingenuity, pushing the limits of our exploration and understanding for over 4 decades. The spacecraft has faithfully sent data back to Earth, exploring the outer planets and venturing into interstellar space. Yet, their mission had always been a one-way street, a broadcast from us to the universe. That is, until now. A response has been received by Voyager 1, a sophisticated, purposeful message from the unknown. What could it mean? Is this an ordinary cosmic noise or random fluctuation? Or is it a reply or something beyond human understanding? Join us as we explore how Voyager 1 just received a disturbing reply in deep space. Launched in 1977 alongside its twin, Voyager 2, these probes were humanity's first interstellar messengers, carrying the golden record, a time capsule intended to communicate the story of our world to extraterrestrials. Now, Voyager 1 has pierced the veil of the cosmos, and the universe has answered back. As Bill Nye says, humanity is on the brink of a revelation that could alter the course of history. Ever since humans acknowledged the enormity of the universe, we have intuited that life must exist somewhere, either in our galaxy or some galaxy far, far away. Given that the universe has billions of galaxies, each containing billions of stars, and that a small fraction of those stars include planets comparable to Earth, it is reasonable to assume that there exist hundreds, if not thousands, of extraterrestrial civilizations. Even more liberal was Carl Sagan, a prominent figure in the SETI movement until his death in 1996, who proposed the possibility of 1 million civilizations in the galaxy. That's a lot of extraterrestrials. It's easy to see why astronomers in the 1960s were so hopeful as they set out on their never-ending search for extraterrestrial life. Life researchers from SETI embarked on a quest to discover extraterrestrial intelligence after estimating the number of communicative civilizations in our galaxy. 2 primary choices were available to them: communicating in person or over long distances. For the first one to work, either aliens or humans would have to travel to the other side of the universe. Given the vast distances between our solar system and other Milky Way stars, this appeared extremely implausible. Radio transmissions, which include the transmission and reception of electromagnetic signals via space, were part of the second scenario. A 210-byte message was purposefully delivered from Puerto Rico's Arecibo Observatory to the globular star cluster M13 in 1974 by astronomers who hoped to signal a civilization there. Data like the molecular formula of DNA and the atomic numbers of important elements were included in the message, which contained basic information about ourselves and our place in the cosmos. However, there hasn't been much of this kind of proactive dialogue. The majority of astronomers' communication strategy is based on passive listening for broadcasts sent by extraterrestrial civilizations. For these kinds of listening tests, a radio telescope is ideal since it can pick up energy waves that are too long for optical telescopes to see. Radio astronomy involves directing a massive antenna toward a nearby star that resembles the Sun and adjusting its frequency to focus on the microwave part of the electromagnetic spectrum. Due to its lower noise floor, the microwave frequency band, which spans 1000 to 3000 MHz, is perfect for this application. Additionally, it has an emission line at 1420 MHz, which scientists have identified as a hiss that echoes throughout the galaxy. Neutral hydrogen undergoes energy changes along this narrow line. Hydrogen is a perfect identifier because all cosmic civilizations should be aware of it as a primal element of the universe. Since 1960, a number of international teams have been methodically surveying the Milky Way and other galaxies for stellar signals. As we continue to explore the planets beyond our solar system, the Voyager 1 spacecraft has played an essential role that no one could have foreseen 47 years ago. Even after all this time, the probe is still sending data about its travels back to Earth, so it must be doing something right. The communication from Voyager ushers in an uncertain but potentially rewarding future. The Voyager missions took advantage of a special alignment of the outer planets that happens just once every 176 years. This alignment allows spacecraft to gravitationally slingshot from one planet to the next, making the most efficient use of their limited fuel. Spacecraft from NASA were initially intended to travel beyond Pluto, Saturn, and Jupiter, while other probes were to travel past Uranus and Neptune. Even though NASA had to cut back on its intentions because of budget constraints, the two Voyager spacecraft it launched were nevertheless quite useful. As Voyager 2 soared beyond Jupiter and Saturn, it also passed Uranus and Neptune, whereas Voyager 1 was laser-focused on those two planets. Two golden records were approved to be installed on board the Voyagers by NASA, which recognized that the spacecraft would eventually go to interstellar space. Sounds ranging from whale calls to the music of Chuck Berry were placed on board, as well as spoken greetings in 55 languages, in case aliens ever happened upon the spacecraft and were curious about their origins. The 12-inch wide gold-plated copper discs also had schematics illustrating how to operate them and the Sun's location relative to nearby pulsars, a sort of neutron star. A trio of radioisotope thermoelectric generators, which transform the thermal energy emitted by plutonium's radioactive disintegration into usable electricity, powers the two spacecraft. A magnetometer, a two-camera image system, various spectrometers, and equipment to detect low-energy charged particles and high-energy cosmic rays were among the 10 scientific instruments attached to the probes. There have been a total of 11 scientific investigations conducted aboard each Voyager by using the communication system to learn more about the planets and moons. On September 5, 1977, during launch, the Voyager 1 spacecraft almost never lifted off because the rocket almost ran out of fuel. Nevertheless, the probe swiftly surpassed its identical twin and departed from the primary asteroid belt spanning Jupiter and Mars. Prior to Voyager 2's ability to re-establish contact at a distance of 165 million miles from Earth, the Voyager 1 spacecraft transmitted its initial images of Jupiter to Earth in April 1978. In March 1979, Voyager 1 surprised NASA by detecting a tiny ring encircling the massive planet. The imagery also discovered two other moons. The large Galilean moons of Jupiter Io, Europa, Ganymede, and Callisto were also captured in great detail by Voyager 1. In the same vein as its predecessor, the Pioneer spacecraft, Voyager 2 found that the moons of Jupiter were dynamic, independent worlds. Intriguing new information regarding these naturally occurring satellites was also uncovered by Voyager 1. For example, the fact that Io is modeled with yellow, brown, and orange and has numerous volcanoes demonstrates that moons, similar to planets, can have dynamic interiors. In addition, images of Europa returned by Voyager 1 revealed a mostly flat surface with lines running across it, suggesting the presence of ice and possibly an ocean beneath it. A large subterranean ocean of liquid water, possibly capable of supporting life similar to that on Earth, is probably harbored by Europa, according to subsequent observations and analyses. On March 5, 1979, Voyager 1 approached Jupiter within 174,000 miles, passing near the tumultuous cloud tops. The probe's next target was Saturn. The only year that scientists had to wait to capture close-up images of Saturn was 1980. Surprisingly, the ringed planet was just as full of surprises as Jupiter. One of Voyager 1's targets was the F-ring, a thin structure discovered only the year previously by NASA's Pioneer 11 probe. Voyager's higher-resolution camera spotted two new moons, Prometheus and Pandora, whose orbits keep the icy material in the F-ring in a defined orbit. It also discovered Atlas and a new ring, the G-ring, and took images of several other Saturn moons. Voyager 1's primary mission came to a close with the Saturn encounter. Following that, attention turned to keeping tabs on the spacecraft as it raced toward interstellar space. Weighing 1,920 pounds, Voyager 1 captured one of the most famous images in spaceflight history. 20 years before it achieved that feat, on February 14, 1990, the probe turned back toward Earth and snapped an image of its home planet from 3.7 billion miles away. The photo shows Earth as a tiny dot suspended in a ray of sunlight. The pale blue dot photograph stands out among the hundreds of other images taken that day by Voyager 1, which included the Sun, 5 other planets, and a multi-image solar system family portrait. This serves as a constant reminder that Earth is a tiny dot in an infinitely huge and unfathomably massive universe. In August 2012, Voyager 1 sprang loose into interstellar space, leaving behind the heliosphere, the enormous bubble of charged particles that the Sun blows around itself. The results came to light after a powerful solar eruption was recorded by Voyager 1's plasma wave instrument between April 9 and May 22, 2013. The eruption caused electrons near Voyager 1 to vibrate. From the oscillations, researchers discovered that Voyager 1's surroundings had a higher density than what is found just inside the heliosphere. It seems contradictory that electron density is higher in interstellar space than it is in the Sun's neighborhood. However, researchers explained that at the edge of the heliosphere, the electron density is dramatically low compared with locations near Earth. After retracing their steps through Voyager 1's records, scientists finally settled on August 25, 2012, as the formal departure date. The electron oscillations in the spacecraft's readings of charged solar particles both contributed to fixing the date. On that fateful day, which coincided with the death of Apollo 11 astronaut Neil Armstrong, the spacecraft detected an increase of 9% in galactic cosmic rays, which originate from beyond our solar system, and a 100-fold decrease in these particles. At that point, Voyager 1 was 11.25 billion miles from the Sun. Voyager 1 has been sending back a wealth of useful information about the interstellar medium ever since it soared into orbit. Among its many findings are proof of the extremely high levels of cosmic radiation and evidence of the interaction between charged particles generated by stars and those originating from the Sun. Engineers are still in awe of the spacecraft's capability. For instance, in December 2017, NASA declared that Voyager 1 had effectively oriented itself to talk to Earth using its backup thrusters. The last time the trajectory correction maneuver thrusters were activated was during the flyby of Saturn in November 1980 by Voyager 1. From that point on, the spacecraft's usual attitude control thrusters became the primary means of guiding it into an optimal communication position with Earth. However, as the attitude control thrusters started to fail, NASA opted to try out the trajectory correction maneuver thrusters, which could let Voyager 1 last longer in operation. In the end, that test was successful. There are further steps that the mission crew has taken to increase Voyager 1's lifespan. To assist in preserving its communication capabilities in Voyager 1's limited power supply, for instance, the cameras on board were disabled not long after the pale blue dot photo was captured, since the cameras couldn't capture much light in space. 5 additional scientific instruments have been disabled by the mission team. At the same time, Voyager 1 stopped transmitting any data to Earth in November of last year, suggesting that it was not collecting any engineering or scientific information. Fixing the fault of the universe's most isolated spacecraft isn't as easy as pie. Problems arose for NASA when the probe suddenly stopped relaying data on the stuff between the stars. Commands transmitted from mission controllers take 22.5 hours to reach the small probe, and the engineering crew must wait the same period again for a response, all because the spacecraft is 15 billion miles away and hurtling along at 32,000 miles per hour. More than 5 months have passed as NASA has worked on the matter. In March, the initial intention was to offer the spacecraft a digital poke. This method is analogous to a doctor using air puffs to identify cavities in teeth. The NASA team sent a command to the spacecraft telling it to relay a full memory readout back to Earth, emphasizing any malfunctioning components. The Flight Data Subsystem, one of Voyager's 3 onboard computers, is in charge of packaging the science and engineering data before returning it to Earth. This chip is where the poke reported malfunction was discovered. Because of the bug, the computer was producing repeating gibberish consisting of binary ones and zeros, giving the impression that it was stuck rather than providing science, temperature, and engineering data. Since NASA had to become creative because the broken chip couldn't be replaced, they had to find a different space in the Flight Data Subsystem memory to store the troublesome code. The scenario became much more complicated because no single site could carry the entire section of the code. So they devised a plan to keep in touch and work together while dividing the affected code into smaller pieces and moving those pieces into the computer's memory. Now, the Jet Propulsion Laboratory of NASA has officially declared that Voyager is back in service following the most remarkable long-range software update in history. We now eagerly await the influx of Voyager 1's scientific data in the upcoming weeks. It is unclear what caused the chip to malfunction, but the team is considering the possibility that it was damaged by an energetic particle from space or just became worn out after 47 years. It's also unclear to NASA if this is a solar or interstellar occurrence. To be picked up by alien civilizations, humans have purposefully transmitted multiple powerful signals into space. Meanwhile, we have also received some signals from space, some interesting and mysterious signals, including the WOW signal. In 1973, the Ohio State University Radio Observatory known as Big Ear began scanning the skies for the slightest traces of extraterrestrial transmissions, blips in the deafening silence of space. On an August night in 1977, the first astonishing signal they received wasn't a whimper but a roar. The data generated by the telescope was not new to Jerry Emmon, a professor from Ohio State who volunteered that summer with the Big Ear program. An office supply of computer printouts produced by the telescope's mainframe computer would be delivered to Emmon by a bike messenger every 2 or 3 days. The arduous task assigned to Emmon was to sift through the monotonous data in search of outliers, anything that could be distinguished from the ubiquitous low-volume background noise. While reviewing data from 3 days prior on August 18, 1977, Emmon discovered something quite unexpected. Rather than the typical sequence of 1s, 2s, and 4s, a steady flow of letters and numbers appeared, indicating a radio transmission that was 30 times louder than the ambient noise in space. Emmon, being the teacher that he was, took out a red marker and eagerly scrawled the word "wow" next to the cryptic sequence 6EQUJ5. Still, after all this time, the so-called wow signal is the closest encounter that humans have ever had with an alien intelligence. Although the intense radio wave burst only lasted 72 seconds, many amateur ethologists and astronomers attribute its unusual properties to a spacecraft. To what end does it seem to many astronomers to be a message from another world? Starting off, we have the hydrogen line to consider. Almost exactly matching the electromagnetic wavelength of hydrogen, the wow signal of 1420 MHz was captured. According to some experts, not even a Type II civilization, the most advanced technologically, would be able to harness enough power to meet the demands. This is according to the Kardashev scale. The wow signal is one of the biggest riddles in the search for extraterrestrial intelligence. Now, a cosmic object that has been pulsing radio waves toward Earth every 22 minutes for more than 30 years has left scientists baffled. The object is thought to be a dying star that is emitting energy from its poles, but it's spinning too slowly to exist. This object stands out due to its exceptionally slow speed and exceptionally consistent behavior. It has been officially named GPMJ 1839-10. Hurley Walker said that while astronomers do anticipate seeing recurring radio signals in space, they often go on and off at significantly faster intervals. Stars can eventually cool down to the point where they become neutron stars, which are very dense celestial bodies that, according to NASA, can fit billions of tons of stuff into extremely small places. From their magnetic poles, some neutron stars emit dazzling rays of light and energy, like the light from a lighthouse flashing to a boat offshore. We only receive the signal when the beam sweeps across our planet. The initial scientists to notice these blips on Earth mistakenly believed they were messages from extraterrestrial beings because of how consistently they occurred. They didn't realize it at the time, but now they know they are the cosmic breaths of a dying star. Researchers anticipate that pulsing neutron stars will gradually decrease in speed until they encounter a theoretical limit called a deathline. Beyond this limit, the stars will eventually collapse due to their insufficient mass. It is commonly believed that this threshold is crossed when the pulses become slower and more spaced out than a few minutes. Additionally, the team discovered that the pulses emanating from GPMJ 1839-10 occurred every 22 minutes, and these could last up to 5 minutes each, defying all expectations. This wasn't the first time a super slow object like this one had been spotted. Another slow object, lasting up to a minute each pulse, has been seen before by the same team. It pulsed every 18 minutes or so. A magnetar, a neutron star with extreme strong magnetic fields, was hypothesized as the source of the beams by the scientists. However, GPMJ 1839-10 possessed an additional surprise that defied science. Hurley Walker stated that the crew discovered the real surprise of GPMJ 1839-10 when perusing archives. This object's pulses had been picked up unnoticed by observatories around the world for years, beaming like clockwork every 1189.57 seconds, give or take a tenth of a millisecond. This goes against what we know about neutron stars. These are expected to die out in months. For instance, the 2018 object only blazed for a short while between January and March 2018. However, the first record of GPMJ 1839-10's pulses dates back to 1988, about 33 years ago. If that's the case, the object might stand in for a completely new kind of star system. Neutron stars and magnetars, two of the most bizarre and extreme cosmic objects, test our understanding of this remarkable object. Regardless of the underlying process, this is very astonishing. Even when they can no longer communicate with Earth, Voyager 1 and Voyager 2 will continue to drift through the galaxy, carrying golden records with information about humanity. The hope is that these could act as interstellar messages for potential intelligent life that may intercept the iconic spacecraft. Would it be a mistake, though, for the Voyager spacecraft to keep broadcasting Earth's coordinates? According to the science fiction novel Battlefield Earth by L. Ron Hubbard, the answer is yes. According to the book, the Coup invaders see Earth as a rim star system located on the periphery of a galaxy in parallel universe number 16. Although it was never completely mapped, this universe was the final one that their race ever discovered. Without the Voyager probes, Earth would have never been found. The Coup invaders, on the other hand, invaded Earth after finding gold, gassed the planet to kill out most of the inhabitants, and then began mining the planet for gold and other minerals, all in the name of banking, interstellar mining, and regular matters for the Coup. In their view, the intergalactic rights belonged to them, and they could conquer entire galaxies and planets with the power of gold. As the Voyager spacecraft traveled away from Earth and into interstellar space, they carried a special message for anyone who'd find them in the far future, the Voyager Golden Record. On the cover of the record, a series of diagrams was emblazoned, including one very important one, a map of Earth's location in the galaxy. Both spacecraft will carry their message with them as they continue to float through space, hoping to be found by a spacefaring civilization with intelligence. Given our current understanding of the galaxy and the possible number of habitable planets, some argue that it is dangerous to openly announce our exact location. The outcome may be hostile extraterrestrials, similar to the Coup from Battlefield Earth. While the original approach to pinpoint Earth's location was brilliant, its inherent flaws have already been revealed. So anybody getting it will likely not be able to pinpoint our planet's exact location. However, the truth remains that the probes from the Voyager spacecraft are still out there. The map is still out there. The code is still up in the air, and an alien race may invade Earth at any moment. Thanks for watching another episode of Space Trailway. While you're still here, make sure to click the video on your screen for more mind-blowing content.